My name is Stephanie Boozer. I'm with CUGC HQ, and I am happy to welcome you to today's user share with Daniel Feller. It is our quarterly XenApp XenDesktop tech update, and I know you guys are excited to hear what he has to say. But first, I have a couple of housekeeping details for you. If you are new to CUGC, we'd like to welcome you to come out to our website, mycugc.org. Find your local group, get plugged in, go to a local meeting. There are lots of resources out there for you. We have lots of webinars, forum threads, and posts to look at, blog posts, all that stuff. Lots of good information for you guys. All right, moderating our Q&A for us today is Eduardo Molina. He is a leader of Kansas City Metro CUGC and a architect at Round Tower Technologies, and you can find him on Twitter at MollyCop. Eduardo, you want to come on and say a little bit about yourself and get us started with Daniel?
Yeah, thank you, guys. Just one thing. It's actually Cincinnati. Kansas City is Jarian. It's Jarian, but that's okay. You know, we look alike. Not. Thank you, everyone, for coming. We're very excited to be moderating and helping as much as I can with this presentation. We were just talking about the presentation, and it's going to be busy. As you guys know, if you have ever attended a session with Dan at Synergy or any other event, he speaks as fast as he can because he has a lot of very interesting content to share with us. I've been doing Citrix since the year 2000, and super happy to be part of this great community. And without any further ado, Dan.
Hey, thanks a lot. The first thing I'd like to actually start with is talking about CUGC real quick. So anyone who's like in the Wisconsin or Illinois area, we're having like I think it's in Milwaukee at the Harley-Davidson Museum, a supersized CUGC all-day event at the beginning of November. So if you are dialing in right now and you're in the Wisconsin or Illinois area, make sure you sign up for it. It should be a really good time. But so here, you know, like you can see, you know, this is what I call volume 16 of the XenApp XenDesktop tech update. So this is the 16th major revision I've done to this deck, and I've probably been doing this now. It's probably coming up in about 3 years doing these tech update sessions, just because people seem to enjoy it. But before I get into the Citrix stuff, hopefully you've noticed that picture on the side. I don't like using the canned photography that you know we get with our Citrix corporate PowerPoint presentations. So I use my own photography. So I actually took this picture a couple weeks ago in Nashville, Tennessee during the total solar eclipse. So anyone who has the opportunity to go see a total solar eclipse, make sure you do it. It is an awesome experience. And you know, if you stay put, you know, you might be able, you know, so this particular eclipse, I could have seen 86% totality, you know, 86% of the sun covered if I just would have stayed home. But a partial solar eclipse is nothing like a total. It is a completely different experience that will, you know, unless you're dead, you know, it's going to amaze you. So, like, you know, if you have any chance in the future to see it, take the time to actually go do it. It's like a once-in-a-lifetime experience. But, you know, although I could spend the next hour talking about, you know, the solar eclipse or other astronomy type things, let's get into the, you know, the reason why we're here. First, you know, there are, how I usually lay this presentation out is on best practices. You know, over the years I've done numerous ways, and I think this best practice, you know, focusing on best practices really works best. And so all these different topics are going to relate to certain best practices, you know, that we have. And the first one is, you know, the best thing in life are free. And there's a lot of free stuff out there. So if you're not aware, I've been maintaining a set of Visio stencils for, boy, more than a decade now. They actually just went through a major revision. So before I used to draw the stencils, and I'm not an artist, not even close, but I can do quite a bit with this square, a rectangle, and a circle. But now we have the Citrix brand team have been helping me create what are probably better looking stencils than I could ever do. So those are out there available either as Visio or PowerPoint, because I know some people are asking for Power, some people are asking. Also, we've been doing, with this 7.6 release, we updated the VDI handbook, and we're going to do this for only long-term service releases. Well, 7.15 was also a long-term service release. So the VDI handbook and best practice document was updated. You can find that on docs.citrix.com. You just navigate to XenApp XenDesktop 7.15 LTSR, and you'll see it on the left-hand side, towards the bottom, the VDI handbook. So again, that will be maintained for LTSR releases, which should happen every 18 to 24 months, not the current releases that are happening like every quarter, but the long-term service releases. There's a lot of other free stuff out there, and I've actually used quite a few of these. I really just keep a running list because it's really for my own benefit, because I'm always looking for certain things. Like I need to simulate a logon. You know what? There's a logon simulator someone created out there. Or you need a reboot script, or the remote desktop analyzer. So all these different tools that different people have created, I just kind of keep a running list on my own site, just because sometimes when I'm doing testing or need to look at something, these tools become really handy. And like I said, I've used many of these before, in my home lab, or recommend it to other people. So it's a good thing to kind of have in your back pocket. So the next best practice is the focus on what matters most. And so this topic really revolves around doing stuff on premises or doing stuff in the cloud, and really everything in between. So on premises, in the cloud, and everything in between. There's a lot of different options that we can go with. And what you're going to see here is I'm going to go run through a couple diagrams really quickly and just show you that for the most part things stay pretty much the same, the architecture, regardless of how you're hosting your environment. So if you're doing XenApp XenDesktop on premises, you've got your users on some device hitting NetScaler Gateway, going to storefront, they hit their XenApp XenDesktop controller, and then they hit the resources. Now all that stuff is running on servers somewhere. It's running on hosts somewhere. In this example, it's on premises. You can also deploy this in the cloud, on some cloud infrastructure, whether that's Azure, AWS, or something else. But the simplest thing is you just deploy this on the cloud, and it's the exact same architecture as if you were doing it on premises, except it's in the cloud. You're using cloud resources. Everything's in the cloud. The other option is to do a hybrid cloud model, where certain portions of your environment are going to be on-prem, and other portions will be in the cloud. And when you do a hybrid cloud, chances are you're going to end up doing, having your access and control items on-prem, and then you would configure your host connections to either your local Xen server, Hyper-V, or vSphere servers, or to your cloud Azure, AWS, hosts, with your keys and everything to get access to those environments. So it's still the same management infrastructure, but your host can now be on-prem or in the cloud. And it's the same, it's the same stuff. It's the same way you have to manage the environment. It's all local. It's what you're used to using Studio and Director locally. And then the final option is what's called the XenApp XenDesktop service in Citrix Cloud. And how this is different is now, instead of the access and control being hosted on-prem, this is actually hosted by Citrix in the Citrix Cloud, where you don't have to manage it. You don't have to manage the updates. You don't have to manage database sizing, storefront sizing, controller sizing, failover and redundancy, and all those type of things that you have to do. When you're doing on-prem, you let Citrix manage it. And then from this hosted infrastructure, you would use connectors, what we call cloud connectors, to your on-prem or your cloud deployments. So again, you can have your different resources, your published applications, your published desktops be in your on-prem data center or in the cloud, or both. And you just set up a cloud connector in each one of those different resource locations that will let that local resource, that resource, be able to communicate up to the Citrix Cloud. So in all, all these architectures are very similar. It's just comes back to the best practices. What do you want to manage? You only want to manage what matters most to you. And for some people, it's going to be this whole list. You want to manage the hardware. That means you're going to rack and stack it. You're going to do the networking, the orchestration. Get all the hardware and size, and plan. How many servers you need to acquire. And there's also the whole access and control, the brokers, the storefronts. Monitoring and troubleshooting. And this is all the all the load balancing, making sure you have enough storefront servers, enough delivery controllers, your database, you have it set up with mirroring with a witness, and you're maintaining all that connectivity and backup and restore procedures for that. And then you have the resources, your published apps, your published desktops, and then the users, which is more or less just the entitlements. What resources do they get access to? So you figure out in that list, what do you care about? What do you want to do? And that will tell you which of these items should you follow. Should you go down the on-prem route where you, as the admin, have to manage everything, end to end, or do you just go down to cloud and you manage everything except the hardware? The hardware this is all running on is managed by, Amazon or Microsoft, or some other cloud provider. But you still have to manage, all the deployment, the infrastructure, the resources, all the users. Citrix Cloud takes it a step further, where Citrix manages the access control, and you just manage the users and resources. Now, there's a star there, just because the hardware is kind of split. The resource hardware, and there's access and control hardware. With Citrix Cloud, the access control hardware is managed by Citrix. You don't worry about it. But the resource hardware, if you do it on-prem, you got to worry about it. But if you do your resources in the cloud, you don't have to worry about it. And then again, you can go down this path and manage less and less by going with Citrix partners who will help manage the resources for you, or even go all the way to the service provider that manages absolutely everything. All the user entitlements, the user groups, the support, maintenance, and all those activities as well. So it becomes this, basically a big decision matrix of, what do I care about? Do I have the resources? Do I have the skill sets to do all this stuff? Do I? If not, then it's like, what? I can offload some of these things to somebody else. I can go down the cloud or the Citrix cloud route, or a partner or service partner. But to build on top of this, the next best practice is maintain, because set and forget doesn't work, and that's what happens a lot of times. I built something and I just ignore it. And once it's built, you have to maintain it. It's just like if you own a house, you have to maintain your house. You're out there mowing the yard, every week, or shoveling the snow off your driveway for those of us who live in the north. Or you have to hire it out. So again, you pick the route that matters most, but no matter what, there has to be maintenance involved, whichever route you go with. It's just a question of who's doing the maintenance. But let's go back to this on-premises architecture. And as you can see, we have two different resources here, Windows apps. And really what this is that most people are going to have multiple silos or load managed groups or images that's publishing applications. You might have one of these might be for mission critical apps, another one might be for financial apps, or different departments or different organizations that you have. They're essentially, each one of these resources is based on a different image. So you have to manage these images. And the problem you run into is if you just with two images, and which is very few. Most people are going to have a lot more images than this. In this one example, there's 17 different things you have to take care of and maintain. You have two operating systems, one for each OS, even though it's the same operating system. You have two XenApp VDAs, even though it's the same thing. You have to manage them both because they're different images. Same with PBS agents, same with your hypervisor tools. Microsoft Office, chances are, is going to be hosted on many different images because a lot of apps rely on Excel. And then you have your departmental apps, all these user apps. You have to manage each one of these. Anytime there's an update, you got to crack open the image, update that image, and if it's one of these items that spans multiple images, you have to crack open all your other images. So if you have a major update for Windows 2012, you have to crack open all those images and update every Windows 2012 R2 portion of that portion. For those of you know, we have an app layering, from Unidesk. This simplifies it. So before it was 17, now it's down to 12 by doing a layering. And for those of you who aren't familiar with layering, I'm not going to go into the whole discussion on layering because Ron Oglesby does a really good discussion on that. I know he's been all over the world for CUGC meetings talking about it. But I want to try to get this across is that in this example, I was able, you're able to reduce how many things you have to manage because you're creating OS layers and you're creating platform layers and then you create application layers. So your layered image, you would pick an OS layer, you pick your platform layer, and then you pick all of the app layers that you need. So in this instance, even though two images, I have two different images, there's only one Windows 2012 R2 layer. there's only one platform layer that has the 715 VDA, the PVS agent, and the Zen server tools. There's only one layer with Office 2016, and then each one of those other apps is its own layer. So if I ever need to update Office with a new, hotfix or a service pack, I update that one layer, and then all of my layered images that utilize that layer get updated and get those, latest updates. So you don't have to crack open all these images. You just crack open Office 2016 plus 20 sat, and then you're off to the races. So now, let's say you go down the hybrid cloud route, and what happens here is that on the resources again, let's talk about these two items, the blue and the red Windows apps. What a lot of people end up doing is using the cloud for adding additional capacity, kind of ad hoc. You don't have the extra hardware, on-prem, so you might have, month-end type activities or year-end activities where you need more capacity, temporary capacity, so you utilize the cloud, and it's a pay-as-you-go model. It's the same. Essentially it's the same image. So here I'll have a cloud image and I have an on-prem image, but I have to maintain these two things separately with traditional image management. But down the whole path of using layered images with app layering, I reduce what I have to manage. So in this case, I'm still using the same OS layer, but the platform layer is different because the on-prem is using PVS and Zen server. So we have the Zen server tools in there, and of course you have the VDA. But if let's say you're using the Azure cloud, all I have to do for the platform layer is include the VDA. You don't use PVS in Azure, and you don't need Zen server tools in Azure. You already have you essentially already have your cloud tools within the operating system. So I can essentially use the same OS layer and the same application layer across a cloud and an on-prem deployment. So it simplifies what I have to manage and maintain in the environment. Now this just isn't for cloud environments. So a lot of people have multiple sites. And you have multiple sites, and chances are you're going to have the same resources being hosted out of these multiple sites, multiple geographies. So you might have a lot of different Windows 10 pool desktops out there, and you have these base images deployed to multiple locations. So in this instance, now I have 3 images that are identical in every way, except they're hosted from multiple XenApp or XenDesktop sites. So it's 24 items to manage. With the layering model, you drop it down to 8. You manage the OS, you manage the platform, you manage each application layer individually. Now, let's say you're using PVS. You might say, well, what? With a PVS vDisk, I can just copy that file to all of my different locations, and it's pretty easy. And yes, PVS is easy. What about MCS though? MCS is a little more difficult because it's based on the hypervisor. So you would have to go in and export that image, import it into your other location, and reconfigure some things, and then push that out to all of your target VMs. So by doing a layered image, it simplifies this whole process across multiple sites. And then I just touched on this. What if you have multiple pools, multiple clusters, or whatever you want to call them? It's just groups of hypervisors. It's the same situation. You're going to have the same image deployed across all of these different pools or clusters. So by using layering, you simplify this overall management process that you have to deal with. And then part of this, the challenge is Windows 10. So when Windows 10 came out, it was, everyone talked about how this is going to be the last Windows desktop operating system, Windows 10. If you've been counting, as of August, there's been 4 versions of Windows 10, and number 5 is coming out any day. I think it's supposed to be out in September. So Windows 10, now we're saying like Windows 10 1507 or 1511 or 1607 or 1703, these different build numbers. Now they're coming out with names. So we had the Creators Update, the Fall Update, the Anniversary Update. We're soon supposed to be getting the Fall Creators Update. But Microsoft is changing, how they're doing these. So now instead of, it's been kind of random, these updates. It's, sometimes it's been a year, sometimes it's been a few months. What they're going to do now is semi-annual. So every September and March, there's going to be a new CV or CBB, which is, they use the semi-annual is what they're calling it now. Use consumer branch for business is what they called it before. So this will come out about every 6 months, and you'll have updates. There's also the LTSB, the long-term servicing branch. That let's ignore that for right now, the LTSB. Let's focus on the CV and the CBBs, which are semi-annual. So how this works now is that Microsoft every 6 months is going to update the Windows 10 operating system. And if you're using the semi-annual Windows 10 builds, you have about 18 months before you have to get off that build. So what it looks like they're doing is that when one build comes out, they will support like the next 3 builds. And since it's going to be coming at the next, that OS will be supported for 3 builds. And if each build is 6 months, then at 18 months, that build you're on is now outdated, and you have to then update to one of the later builds. So before, how many years were we on XP or Windows 7? A long time. If you go Windows 10, the CB, the CBB, or the semi-annual route, you're going to be on that Windows 10 version for 18 months, at the most. And then Microsoft will stop updating it. So what you can see here at the top, the 1507, the original, they updated this 30 times and it stopped because the end of servicing happened in May. The 1511, that came out in November 2015. The end for that OS is coming up in October. And they've had 37 updates, and they'll probably get 1 or 2 more before it's done. And then you have to be on 1607, 1703, or this next one that's coming out. And then when it comes to March, chances are Microsoft is going to have the end of servicing being for 1607. And then again, this just continues on and on and on. So if you're doing these semi-annual releases in your environment, you need to be able to find a way to make it so that you can update your OS easily. And again, this brings us right back to app layering. So here I'm using 1507. I just go in and update the Windows 10 layer. I'm at 1511. I don't touch anything else. Then I'm at 1607. Then I'm at 1703. Layering will, being able to layer the OS makes trying to maintain the Windows 10 OS much easier than doing a traditional the image management way where we have multiple golden images that we're maintaining one by one. So, with all these different updates for Windows 10, this always brings us into how do we optimize it. And there's a lot of optimization stuff, and this is one of the best practices. You have to optimize, but don't break anything, because when you start optimizing stuff, you tend to break things. You start turning things off that you shouldn't be. And really, because of how Windows 10 is being updated, the best practice kind of changes to be continuously optimize. Not just optimize once, but continuously do it. What I did is I looked at the 1507, 1607, and 1703 versions of Windows 10. Now I was trying to compare them to see how much changed between these 3 releases from Microsoft. And so I was doing, just doing standard, login BSI tests across these different OSs. So it's the same workload to see what would happen to the CPU. So the blue line here was the 1507. So this is my baseline. And then we went to the anniversary update. That was 1607. And so you can see the lines actually match up pretty well, but every so often you start seeing the green peaks a little more here and there. And then we went to the creator update, and that was the 1703. Again, the orange line peaks higher than the other ones. So each one of these releases is utilizing the CPU just a tad more. So that's looking at CPU, but what about memory? So when we look at memory, we do the same thing. The blue line, this is how much available memory is left on my virtual machine. So I'm getting down to about 1 gig left. Here we go, the anniversary update. It's lower, and then the creator update, slightly lower. So the anniversary and creator update were much lower than the original, but not much difference between the two. So you start looking, trying to understand, okay, why is this, and okay, and so you start looking at what are the differences within these different versions of Windows 10. So again, using the same color scheme, you look at all the default apps, and these are, like Calculator, People, that 3D modeling app that they now have, Bing Weather, Bing Sports, Finance, all those different default applications that pollute your start menu when you first install Windows 10. This is what I'm talking about. There's more. Each release, there's more. And I can bet you a lot of money that the fall creator update coming out any day is going to have even more, because there's going to be more 3D type applications in there that they're going to be adding. Those consume resources, those consume RAM. Services. Windows 10 is not a static OS. Microsoft will continuously add new capabilities based on new technologies that are out there, and this usually results in more services. And this is what happened over the last 2 years with Windows 10, is that we have more services. And then we also have, from the original to the anniversary, we had a massive increase in the number of scheduled tasks, but surprisingly with the creator update, it stayed fairly constant. So they removed some of the scheduled tasks or merged things together. So you have to go back, and every time you change your Windows 10 build, you need to go back and re-optimize it because things changed. So one of the crazy things was I think it was a service that we recommend turn this particular service off in the original release, and then in the creator and anniversary updates, that service no longer existed. It actually still did. Microsoft just changed the name of it. So when you actually looked in the services console, the name changed, so it was harder to find, but the actual file name itself was the same. So they're using the same thing, that's changed what the name was. And again, we still recommended shutting it down. I think it was like the Customer Improvement Program. So this, even though it added more services, more scheduled tasks, it used more CPU and more memory, it didn't actually change how we recommend sizing Windows 10 VMs, in a VDI world. That's because if you optimize Windows 10 OS, you can actually get these newer builds to get very similar performance as the old builds. So you might not get the same single server scalability, but we want to give it the same resources. We don't want to, it's never going to require fewer resources as you get a newer operating system. It's always going to require more. And so that's why we're not breaking the sizing of these virtual machines down based on builds. For the desktop OSs, we do break this down though into, are you trying to optimize for scale, density, or the user experience? It all depends what you're trying to do. Depending on your user groups as well. If you've got some people, user groups who need the performance, maybe they're crunching a lot of big numbers, huge Excel spreadsheets, or they're doing serious graphic manipulation, they need an experience. But if you got people who are mostly just word processing or data entry, they probably just need density. So you need to kind of look at the user groups and figure out, okay, this user group I'm going to optimize for density, and this user group I'll optimize for experience, and that will impact how much RAM, how much CPU, how much I/O cache you're going to give cache or VMs. So the next thing to optimize is Windows 2016. So this has been out. This has been out for a while, and so we do have some numbers on it, comparing it to 2008 R2, 2012 R2, and then 2016. So the first bar here, higher is better, and it's all percent based. And so we're trying to look at what is the percent reduction, or what's the percent impact that we have by changing operating systems. And of course, as you would expect, newer operating system, you get less density because the operating systems are bigger, they're doing more things. So from 2008 to 2012, you lost about 8% density, but 2008 to 2016, you're down about 20 to 22%. It's been like over 8 years, so there's a lot more in the operating system. It's doing a lot more than 2008 could ever do. So that's why there's a big reduction in overall density. Now, if you're still running 2008 R2, chances are you're still running on the hardware that you originally built those servers on, and that hardware is probably out of warranty. Stuff's going to start failing soon. So even though 2016 has less density based on the same hardware as 2008, chances are when you upgrade, you're also going to be upgrading your hardware. And the hardware is a lot faster over the last 8 years too. So you probably won't notice a reduction in single server density, because you're going to have newer servers that are going to be faster and to be able to handle the operating system in the newer applications. Now for the other three portions of this graph, lower is better. So you look at CPU, and again, this makes sense. 2008 utilized the CPU a lot less than 2016 or 2012 because, again, more stuff's going on. The surprising thing was RAM. 2008 was a RAM hog. It was not very efficient, but again, Microsoft did a lot of improvements in the whole memory management in the 2012 release, which is why there was that massive reduction in RAM utilization. And then I/O, 2016 had a huge increase in I/O. It's going to impact your IOPS. It's going to impact your storage. So different, things to take into account. And so when we came up, with the sizing of XenApp VMs, based on these server OSs, what you end up getting is slight differences. For virtual CPU, it's still the same. Each one of your XenApp VMs, the number of virtual CPUs you're going to give it should be equal to NUMA or half your NUMA. And if you go half of NUMA, you double the number of VMs. And if you don't know what NUMA is, just go to the Citrix blog site and look up Nick Rintala and NUMA, and he's got an article on there that explains it really well. But that's the approach you want to go with. RAM, again, there's really no difference in RAM. And the graphs we saw, 2016 had a little bit higher RAM utilization than 2012. But again, if you optimize 2016 OS, you can reduce the RAM utilization. It's the disk and I/O cache. Because it's a bigger OS, you probably need a bigger disk cache. And because it's hitting IOPS more, significantly more, we probably want to increase the RAM I/O cache, the write-back cache for PVS as well as MCS, because it includes both of them. So, some different sizing things that we want to, take into account when doing 2016 VMs. The next thing is Azure. How do we, let's optimize Azure. And how do you do this? I mean, we don't own the hardware, so how do you optimize Azure, if you're going to start deploying XenApp in the cloud? So,
hey, Dan.
We did the test. Yeah.
Just a quick question here that I think is relevant for your comment. When you were mentioning this cache size, were you referring to the PVS or MCS disk cache?
It would be both. So it's because they both now do the RAM cache with disk overflow, although I think they call it differently. But it's the same thing. So whether you do MCS or PVS, that's the RAM I/O cache, and that's just how much RAM from each of those VMs you're going to allocate for I/O activity. So significantly, not significantly higher, but higher when we do 2016 as opposed to 2012, and that's kind of like the baseline that we would recommend. Again, your apps and what your apps are doing will influence these numbers up or down as well. All right, so Azure. So we did all these tests comparing task workers, knowledge worker workloads across, if you looked in Azure, they have many different types of virtual machine instances. And when you look at this, of course, knowledge workers are going to use the system heavier, so there's going to be a reduction. It's about 25% reduction in capacity on a Azure VM instance. So based on this, if you go with the old logic that you would have with an on-prem, that you're trying to pack as many users, you end up getting the bigger servers and get as many users on those servers as possible, you would be thinking the D13 V2 is the way to go. And that's going to give you, for knowledge workers, close to 60 users. But when we look at the cost, that's not really the way to go. What becomes the cheapest is D2 V2. This brings us into $0.0186 per hour per user. And so, here's how it works: is that the D2 V2 is about 15 users. Now, based on the cost of that, if you divide the cost of that VM instance for 1 hour, you get a certain dollar amount. Then you divide that into 15 users, and that comes down to, $0.0186 per hour per user. And that's what you end up getting. Now, the D13 V2, it's pretty close. It's just a shade over 0.02, shade over 2 cents per user per hour, because there's like 60 people in that box. So that instance costs a lot more than the D2 V2, but it holds a lot more, so it brings the overall price per user per hour down as well. So I would be thinking, it's like, okay, that's not much. I could essentially take one D13 V2 is 60 users, D2 V2 is 15 users, so I could do 4 D2 V2s, and that equals one D13 V2. Hopefully that makes it. Hopefully that go back to this again. So the prices are similar between the D2 V2, 15 users per box in the D13 V2, and I'm just going to say 60 to make this whole easy. So if I take 4 D2 V2s, 15, 30, 45, 60, I should equal 1 D13 V2. Is not really how you want to look at when you do cloud. With cloud, you got to focus on cost and not so much on the capacity or the scalability of a particular instance. And here's some of the reasons why. So you're charged per instance. And what's kind of misleading about, let me go back to this chart, what's misleading about this chart here is that, the D2 V2 is, 1.86 cents per user per hour. D13 V2 is 2.01 cents per user per hour. This is assuming you have completely loaded up that VM with 60 users or 15 users, based on which VM you picked. If you don't, then the cost per user increases because you haven't maximized the capacity of to this. What you end up seeing is that, yes, I'm that a lot more D2 V2s, which is the blue line, but every time I hit 15 users, it has to increment 1, and these little bumps are going to be tiny, and you see them going all the way up. The D13 V2s, you got massive jumps. 60 users, I now have to add 61st user, I now add 1 user. That 1 user is very expensive until I get 59 more users on that box. So each time you have to add a new instance, there's a larger hit, a larger cost per user. And so as of September 7th down here, the D2 V2 was 28 cents per hour. The D13 V2 is $1.17 per hour. So if you can load up a D13 with 60 users, it becomes almost as cheap as the D2 V2. But again, every time you scale up and you don't maximize out that server density, you're losing money. And with cloud, we're focused more on the cost and not so much on. The other part of this I looked at was power off savings. So this was interesting. So imagine the scenario, you've got 1,000 users running in the cloud on Azure. And they're all concurrent, 1,000 concurrent users during the day. But after hours from 9 to 5, they're all working. But then from 5 o'clock at night until 9 the next day, everybody logs off except for maybe 100 users, and they're still working. Now you can power off VMs, and that's going to save you money because you're being charged per active instance. So you want to shut those machines, those Azure machines off. It's going to reduce your overall cost. But you can only power off servers with no users. And the problem with a multi-user environment like XenApp, an RDS, is that you can't live migrate active sessions or user sessions. You can't do it. You can only migrate whole VMs, and that doesn't buy you anything. So we can only shut off these Azure instances when all the users have logged off of that one particular instance, and we don't know who that's going to be. It's all random. So what I decided to do is I ran 10 tests to see if I had 1,000 people on, and then I logged 900 of those off, how many of those boxes are going to be empty that I could potentially shut down and say shut down. And this is what I got for the D2 V2. So I had to, in order to support 1,000 users on the D2 V2, I needed 67 D2 V2 instances, 67 VMs. When 900 of those 1,000 people shut off, 15 of those VMs on average had no users. So that's what this graph is showing you. Out of all those 67, this is how many on the 10 different tests that I could be able to shut off and start saving money. And it averaged out to about 15 instances. D13 V2s, I only needed 16 instances, and I could not shut any of those off because those 900 users, or those 100 users that were left, were still spread across all 16 users, and there was nothing I could do about it. So I could not shut anything down. Actually impacted the environment. So look at it this way: 67 D2 V2s or 16 D13s. I was able to get rid of a big hunk of those VM instances night.
Dan?
Yeah.
Your voice is starting to break up a little, and then we can hear the thing echoing or repeating itself. So, just letting you know.
Okay. Yeah, I'm not sure what to do about that.
Yeah.
Is it better, or maybe I'm just talking too loud?
It's happening right now.
Oh, okay. All right. Well, hopefully it'll clear itself up. It could just be network latency or something. So the these D2V2s these 28 cents per hour per instance. I have 15 instances, a VM instance per day. It's 15 hours per day and 30 days per month. So if you calculate this out, being able to shut down 15 VMs on average would save me $1,890 a month in being able to shut off VMs because they're unused. Because I don't get any D13s. So if you look at this for the entire year, what you end up seeing is a difference of about $40,000 in cost to use the bigger machines. If I use smaller machines, I will save $40,000 based on this example of being able to power off these unused VMs. Just because the D2V2s are smaller, and that there's less users, and there's a greater probability that one of those smaller VMs will release every user on that VM will log off, that I will be able to power it down, after hours, which will save me more money. So again, when we talk about cloud, you focus on the cost and not the size. When we're on-prem, we need to do it focus more. We usually focus more on size. So Eduardo, has it gotten clear, or should I dial in real quick?
I will say, why don't we dial in, Dan?
All right, give me one moment.
Thank you, everyone. Well, Dan is dialing in. There have been some quite interesting questions out there that we have been trying to answer as fast as we can. Please do use the question or the question box on GoToWebinar. For those questions that we won't have an answer for today, we don't get to answer right away, we will email in directly, or what we usually do is create a quick blog post in my CUGC to answer some of those questions. We also recap them on it. There's Stephanie's also telling us there's a forum thread for this webinar that you guys can use. It's available on the chat side of the webinar. You can follow that there also.
All right, is that better?
So far, so great.
All right. That's the first time that's ever happened.
Yeah, there was actually one question that somebody asked, are we sure this is Dan or some crazy IA that he created?
It was actually, this was interesting looking at this, because more people are getting into starting to look at cloud and how to do things, and so we're starting to look at cost, and it's like, oh my God, I can't believe I'm going into all this math now. So it was this is an interesting exercise here. So back with the whole cloud, it's focused on cost and not so much on size, because with cloud you don't care about VM instances and you don't care about the hardware anymore. Managing the hardware, Microsoft does that, or Amazon does that. All we care about is how much is it going to cost me, and then you let the Citrix infrastructure handle load balancing users across different servers, or spooling up more VMs and creating more VMs for you with MCS. And so it does all that, so you don't have to worry about it. So that's why the number of VMs isn't that much of a concern. It's more or less the cost. But the next part is network. As you can see, there's a lot to optimize, and I think I have a couple more after this. But the network is so here we're looking at PVS. And so with PVS, this is PVS Accelerator. So when we look at PVS, we have the OS disk has to come from our shared storage. We have our hypervisor. All these machines have to stream up, and it uses the network. So we've always recommended is, make sure you size your PVS server appropriately with RAM, so that we can use the Windows operating system to be able to cache our master image in RAM. And typically we say 2 gigs of RAM for every image that PVS server is going to stream. But this does nothing for the network. From the PVS server to our target devices. So every VM you build, it's a linear progression of how much data crosses your network. So it takes about 250 about 250 megabytes to boot an OS with PVS. So if you had 1 is 250, 2 is 500, 4 is 1,000, and it just goes up linearly. And then as you use this, you keep streaming more information, more data across the network. So now there's this whole PVS accelerator, which caches locally on the Xen server hypervisor. So the first VM boots, it hits the vSwitch on Xen server, it goes to PVS accelerator cache, nothing's in there, now it goes out to PVS. And PVS streams the information back like it normally does. But that stream back gets cached locally on the Xen server into the accelerator cache. So now when another VM boots that's using the same image, and that's typically what happens, it's the same image, the vSwitch sends it through the accelerator cache, the cache has the info, and the VM automatically boots without contacting the PVS server. So this results, instead of having this linear progression of how much data is crossing the network, it actually goes up once and then flatlines. So it's the first VM has the, takes the hit, and then everything else just uses the cache. So again, we looked at the results, what impact did this have besides, just lowering network utilization? So first, it actually dropped PVS, the CPU utilization, because we're not using the PVS server anymore for all these VMs. It also dropped network throughput, of course, that's no surprise because it's all cached locally. But it also reduced the VM boot time because it's not going across the network. That adds latency. Even though your network might be fast, it could be 10 gig per second, it's still not as fast as coming from your local cache. That could be RAM. And then let's say you had a 4 gig cache, PVS accelerator cache configured on your Xen server hypervisor. So what I decided to do is look at a user workload. And so the blue line here at the beginning is the boot of the first VM, and the big red blob is how much traffic's being sent. And so you can see the scale on the left is showing the data, and then the scale on the right is showing the overall cache used. So again, boot, huge increase in the cache. First user logs in, increase the cache a little bit more. And then steady state, we increase the cache a little bit more because we're starting to load applications. And each time an app's loaded, you can see it tick up a little bit. The next blue line is the second VM starting. The next green section is the next logon, and the next orange is the next user actually doing work, using similar applications. As you can see, there's nothing. Even logging in doesn't really impact because it's for the most part the same information from the operating system perspective. Of course, there's profile, but that's not stored on the PVS server, so loading your profile doesn't impact PVS. So we did this on Windows 10. We looked at it again on 2012. R2, same thing, except we used a lot less cache, even though they're the same. Windows 10 used the most cache. And then 2016, again, it's the same format, and this actually was right between 2012 and Windows 10 on how much cache it was using. But again, it's the same overall look between it, the same overall structure that's happening here. So the next, well, I've got like 10 minutes left. Okay, I got time to speed up even more. Optimize CPU. So I like to call this, from the words of Spock, the needs of the many outweigh the needs of the few. When we look at how to optimize CPU, and this is workspace environment management. So all of your processes that are running on your system are at a normal CPU priority. For the most part, everything's going to be configured normally, and it all works fine. The problem we run into is one of those resources, one of those processes is going to consume the CPU and just monopolize it and not let it go. And this is actually very easy to do. So I created a video on this, and I created a VBA app in Excel that would make kind of this retro-looking, graphic equalizer thing, but it would show, it would change this graphic type thing based on perfmon counters. I pegged the CPU, 4-processor CPU, I pegged it with this stupid little VBA app in Excel. So I was doing something work-related, and I could have impacted absolutely everybody else in the system because no one else can do any work when one process monopolizes the CPU. So what Workspace Environment Management does is it sees that process consuming a certain % of the CPU over a certain amount of time, and it drops the priority through low down to very low based on how severe it is. Now, the process will continue to function, except it functions at a lower priority, so every other process on that system has a higher priority and will be able to continue their work. When that bad behaving process, starts behaving again, Workspace Environment Management brings it back up to a normal level. So again, the needs of the many on this one system, all those processes outweigh the needs of that one little app, that one little process. So that one little process must get a lower priority so everybody else can continue to function. So that's the Spock optimization that I like to call it. The next one is the RAM optimization. I don't have any cool Star Trek names for this, but it's memory optimization. Again, it's Workspace Environment Management. And this was my virtual desktop that I use every day. So I looked at the RAM, my RAM utilization. I had 4 gigs of RAM, and I only had 5% left. And 60% was my apps. Everything else was services and background processes. So I look at my apps, Firefox. Firefox is using almost 75% of my RAM. So, and I had like 4 tabs open, and that was it. But one of those tabs is, you know, one of those websites where you just scroll and it keeps loading more and more junk on the bottom. That's what it was. And other sites probably, you know, other tabs had advertisements that were running and you know, the stupid memes, you know, animated GIFs and all that type of stuff. So it consumed my resources. So this is what my RAM consumption looked like through perfmon as I was using it. You can see it spiking up and down, you know, as I'm using and going through different websites. And then when I finally minimize it and actually do some real work, it drops a little bit, but it flatlines. It doesn't spike so much, but it only goes down to 1 gig. That's how much it's still consuming. WEM, you know, Workspace Environment Management, sees that we're no longer, you know, active, and it will free up that working set. It moves the working set memory of that app down to, you know, down to disk. So it frees that RAM back up. And then when you start using Firefox again, it pulls it right back into the active working set. So this not only works on normal applications, but if you looked across the entire, all the different processes that we're running, it impacts everything. So of course, you know, we talk about Firefox, about the massive reduction there, but look at like Citrix graphics on the right. It went from 56 meg down to 2. You know, I have no control over that. That's a system process. Same thing with Windows Shell Experience, the desktop Windows Manager. So this is optimizing everything and freeing up a lot more RAM on the environment. And then the next one is Logon. So I did a, you know, informal survey on my site. You know, how long does Logon take? And a lot of people, it's 31 to 90 seconds. You know, the big pink line is 31 to 60, and there's some 61 to 90. You know, it gets really painful. There are ways to optimize this. You know, so with the default OS, Windows 10, it took about, when I tested this, it took about 42 seconds. When I ran through the optimizations, you know, different optimizations that are out there for Windows 10, it dropped down to about 36 seconds. When I did PVS Accelerator and that cache thing we just talked about on Zen Server, it dropped down to, I think that's about 33 seconds. And then if I did the cache and RAM with overflow to disk, it dropped it down to about 27 seconds. So that was the lowest I could get in this certain test environment, which was not enterprise-grade hardware. So I got down to that level, but I haven't done anything yet. I haven't customized my environment yet. So when you look at the overall logon process, what happens is that when a user logs on, the shell initializes, and then the profile loads, GPPs are applied, login scripts execute, drives and printers are mapped, and then we see the desktop shell. That gets initialized. That all takes a lot of time. Most organizations have a lot of different things set in each one of those red boxes. What Workspace Environment Management does is it pulls that out of the normal logon process and applies it after the shell has been initialized, so after you see the desktop interface. So now what the user experiences is the session and the shell initialization, which takes 5 to 15 seconds. They have their desktop, and in the background, the WEM agent is very quickly loading everything else, doing your logon scripts, mapping drives, printers, you know, and GPPs, because chances are you don't need that stuff yet. You're not in those apps. So this graphic is a little, you know, the more correct way is those items are actually still up in the login process. It's still, the login process is still seeing if there's any GPPs applied or any login scripts that need to execute or any drives that need to be mapped, because that's just part of the Windows logon experience. The deal here is that we actually say do not set those in Active Directory. Set them within Workspace Environment Management. So when it queries AD, these things, it's like, yeah, I have no login scripts, next. I have no map drives, next. I have no map printers, next. And so it is able to parse through these really quickly. So now what happened is I added 5 map drives, and this is where we start seeing a little divergence between the native and the Workspace Environment Management numbers. 5 map drives, with WEM, the number stayed the same, but with the native, it starts to increase. When I map 3 printers, now I'm back up into the upper 30s. When I run a simple logon script that checked one Active Directory group to see if I was a member of, and if I was, map a drive, I'm now in the 40 seconds. And then with a single user roaming profile, I'm over 55 seconds. And now that user profile was 250 megabytes in size. It wasn't, 10 gig. It was 250 meg in size. So pretty small roaming profile had that much of an impact on my overall logon time. So this is a lot of different optimizations to look at in the environment. Some are looking at how the OS actually performs, and other ones is looking at the user experience, but you've got to look at the overall optimization of the environment. Now, the last best practice is, really for me, is during presentations, watch the clock, because there's 4 minutes left for questions. But first, some things to keep in mind. Visio stencils, that's where they're at. All the freebies, that's where they're at the same location. And no, not all these updates are going to be pointing to that same site. The 715 VDI handbook, doccitrix.com. Layering is going to help you with the operations side of managing and maintaining a XenApp XenDesktop environment. So if you haven't yet, seriously take a look at it. If Ron Oglesby is coming to your local CUGC, make sure you go there and get the info on it. And then optimize. Windows 10 is going to be ridiculous. It's essentially new operating systems every 6 months that we're going to be going under, and you're going to be forced to do it every 18 months unless you're on the LTSB. And then you can achieve 15-second logons if you look at your logon process and try to optimize this. And then before I open for questions, just something fun, if you have some time, go to YouTube and search Seagulls, Stop It Now, and enjoy. I love it. And then it's time for QA, and Eduardo, you get to answer everything.
I have been trying to. There are a couple things that I thought it was good for everybody to hear about. One is obviously not only Firefox uses a lot of CPU. Internet Explorer is also one of those things that when we do assessment we see all the time high up there. So Kevin is asking us, can you use the CPU optimization also for Internet Explorer? For what? Internet Explorer. Can you use the CPU optimization? So with the CPU optimization, you can tell it to ignore certain processes, but it will look at all the processes on the system that are running. And how it works is it just looks at all the processes and sees, it's like, okay, is this process using a certain percent of my CPU over a certain length of time? And now that percent and that length of time is configurable. So you could say, is this process using 60% of my CPU utilization over 20 seconds? And if so, WEM will then take that process and drop it down to a low priority. And then when it doesn't need that many resources, WEM pulls it back up to normal. So it's all kind of automatic on you. And you can configure it to say, I don't want this process impacted, because there might be a legitimate process that's going to be that needs all the CPU resources. And I think we might have time for another quick and easy one. How are you capturing all those charts? Are you using any monitoring tool?
Capturing all the what?
The charts, the graphs?
Charts?
Yeah.
I actually wrote some I do some with Perfmon, and then I do a lot with PowerShell to dump it into a CSV file for me, because I find it a little easier, especially when I go down to the hypervisor level, since there's no Perfmon there. So it depends on what it is. I will use one of the two for the most part, and then dump it into Excel and see what I get in the data.
Awesome. And with that done, we have gotten to the 2 o'clock top of the hour. And I want to thank everyone on the call today for attending. I want to thank you for giving us so much information throughout these years. It's been quite a ride with you guys, and I'm turning it back to Stephanie.
Okay, thanks. Thank you so much, Dan. Thanks, Eduardo. Eduardo from Cincinnati, not Kansas City. Been doing a lot of webinars lately. Just really quickly for you guys, want to let you know we have a lot of content coming up on your screen. You can see we have something from Goliath, and then another user share with Dave Brett and Esther Vartel coming up. It's going to be a big one. And I put a link in the chat window for you to the current webinar calendar. And then also, this is a really big webinar we have coming up. It's our User Share XL. It's focused on security. You can see a lot of familiar faces on this screen. So scoot on over to the webinar calendar and you'll get all the information on this. Love to have you sign up. And finally, and very quickly, we're going to put a link to the survey for you in the chat window. There you go. We'd love to get your feedback on today's presentation. It always helps us out to know what you guys are thinking, what you're interested in, and if you have any comments for us. And with that, I will let everyone get back to the rest of their day. Thanks again, Dan. Thanks again, Eduardo. It was great to have you guys on, and looking forward to doing this again in the future.
Thanks a lot.
Thank you.
Bye.